Hello, I greet dear friends. In this session, we want to examine the Ichimoku indicator. Indeed, by the end of this session, we will be able to plot these charts. It is worth mentioning that during this session, in addition to explaining Ichimoku points, professional points related to Python will also be discussed. Well, we will continue by explaining each of these written codes. As you can see, these codes may seem complex, but in this session we explain them simply. If you remember in previous sessions, how to obtain information from the exchange and its correlation was discussed. Similar to previous sessions, by simply calling a function, we obtain information for each cryptocurrency at each time frame and candle count. Also, how to draw candlesticks has been discussed specifically in previous sessions. Here, to draw candlestick charts, the Plotly library has been used. Here we import graph objects from the library using the abbreviation GO. For numerical implementation, we also use the NumPy library and import it with the abbreviation NP. It is worth mentioning that the previous libraries are still present. Well, here we obtain the desired information from the exchange using the createExcel function. In fact, the next calculations and charting commands are based on the data obtained from the exchange and organized. Here, as an example, Bitcoin data is stored in 1000 candles with a 4-hour time frame in the prices variable. Friends, please try to be a little more focused in order to understand the content well. Next, we have used the code that automatically extracts the time frame based on the data. In fact, if I change the time frame to 1 day, here the frequency variable changes automatically. For further examination, we will specifically address this code here. In fact, with this action, we want to fully observe the output of these commands. Here, first we type the command to print the close price from the prices data frame and then execute it. Well, the closing prices are displayed. Now, how is the frequency variable calculated? Actually, by using the Pandas library and the interfreq function, the time frame is extracted based on the data frame indices as input. In fact, based on the intervals between rows, this code extracts the time frame. Now we print this variable. By running it, it can be seen that the time frame is correctly identified. Now here, in the createExcel function, we obtain 4-hour information from the exchange. Now by running it again, the code calculates the interval between rows again and print the frequency variable correctly. Now we will see what these codes are for. Friends, please note that in plotting the Ichimoku indicator, a part of the chart refers to the future. In simpler terms, by observing the chart, a part of the chart corresponds to the future. In fact, our data is in this form until January 31st, and we have also plotted data until February 4th. Now, how can we extend the data obtained from the exchange and time frame indices to the future? To do this, here we use the Pandas library to generate indices relevant to the future. Here, we use the dateRange function of the Pandas library. This function has 3 inputs. The start variable is equal to the index or the last datetime data obtained from the exchange. We also consider periods to be 26. We will explain later why 26 is chosen. We also set the frequency variable to the calculated frequency. Actually, it's better for me to specifically address this part of the code again. Now here we copy these codes and specifically examine them. If friends want to practice themselves, they can execute the commands step by step to become proficient. Well, in the first step, let's examine the -1 index of the prices data frame. For this purpose, we print it. By running it, it can be seen that by doing this, we access the datetime data and in fact the index of the last row of data. In other words, the first input of the dateRange function is this variable. Now we consider the periods to be 26. In fact, with this command, we will go 26 units of frequency into the future. For example, we move 26 units 4 hours ahead. For clarification, we print the future indices. Great, here, based on the entered date as a start and the specified frequency, we have moved forward by the size of periods. In fact, we have added 26 extra indices based on date time to the end of the data obtained from the exchange. Now, using these generated future dates, we proceed with our work. Now, the question arises, how do we add these dates to the price data frame obtained from the exchange and time frame indices? For this purpose, we return to the main code to see how to add these dates to the data frame. Here, first a new data frame is created with the new dates. It should not be forgotten that the dates of the prices data frame are exactly up to before the first date of future indices. Here, the command to create an indexed data frame based on future dates is typed. Here, also using the concat function of the Pandas library, we define and create the extended prices variable. With this function, the prices data frame and the future data are combined and the extended prices variable is created. For further clarification, we examine these parts separately. Here, to observe the data frame based on future dates, we print the future data variable. With printing this variable, a data frame is defined that doesn't yet have columns, only having a time index. In fact, this data frame simply generates future dates as empty rows. But by doing the concat function of the Pandas library, rows based on future dates are added to the previous prices data frame. Here, by printing extended prices and specifically its close price column, we hit the run button. As can be seen, this new data frame also includes future dates. For a more detailed examination, with the help of the tail command, we print the last 30 rows of this data frame. By running it, it can be seen that the last 26 rows of the future dates for which price data doesn't yet exist. In fact, here the price is specified for the date of January 31st, but for after this date only the dates are specified. The number of these future dates is 26, which is the default value of Ichimoku, which we can change as desired. As another example, we can also print other columns such as high prices. Now, the next question is, what can be done with this data frame containing past and future dates? We will answer this question in the next session. In the next session, we will calculate the Ichimoku indicator. Thanks.